Okay, welcome back. Let's move to the next question. The next question is in part question one. We have to find we have to discuss about part C question. Part C question. The question is the specific heat capacity of the gas at constant volume. We have already in part 2 video we already discussed about the specific heat capacity of the gas at constant pressure. We already find constant pressure. Now we have to find the heat capacity, specific heat capacity of the gas at constant volume. How to find it here? Now, okay, we already know. Now we already find Cp. We already find the Cp, which is equal to Cp. We already find 0.8, 0.82, 8274, 0.8274 kilojoule kilogram minus 1 Kelvin minus 1. Right here, I have to write here, but okay, kilojoule, kilogram minus 1, kilogram minus 1, Kelvin minus 1. Okay, Kelvin minus 1. This is the answer of part B. Now we have to discuss about part C. The specific heat capacity of the gas is constant volume. Yeah, let's discuss about here. If we want to find the specific heat capacity of the gas as constant volume, we have to use a equation. This equation is called Mayer's relation. That equation is called Mayer Mayer's Mayer's relation. Mayer's relation. Uh, the- okay, we have to use this Mayer's relation to find the specific capacity of the gas at constant volume. Okay, that relation is R is equal to Cp minus Cv. Cp minus Cv. This is the equation. Okay, R is equal to Cp minus Cv is the uh, Mayer's relation equation. We already found Cp is equal to 0.8274 kilojoule kilogram minus 1 Kelvin minus 1. Not only we have already find in part A equation. Part A equation we already find that this R is not a RU. RU means universal gas constant. But here this R is not RU, this is RC, but we don't include R. Only we mention R. We don't mention U or C. We don't mention. We only mention R. Here the R means characteristic gas constant, not universal gas constant. This characteristic we already find in part A question. If you find, if you please check the first question, characteristic that R is here. R is equal to Cp minus Cv. It's simple. If you memorize this equation, you can quickly find it. Don't if R is, we already find that R is equal to 8.314 kilojoule mole minus 1 Kelvin minus 1. This is this R is universal gas constant. Kilojoule mole minus 1 Kelvin minus 1. Please check again. Uh, uh, Joule, I think Joule. Okay, we don't need this. Don't substitute R. This number for R. This is RU, universal gas constant. 8.314 joule mole minus 1 Kelvin minus 1. This is we use for ideal case. Now, this R is not this 8.3. This R is not 8.314 joule minus 1 Kelvin minus 1. That R is equal to Cp minus Cv. No, this is Mayer's relation. We already find Cv, not Cv. R is equal to Cp minus Cv. This R is we already found the number uh, is correct special characteristic gas constant. This R is, oh, now we substitute R is equal to, we already found R is equal to 0.14. We we move the, what we found, we have to find CV. Therefore, CV is equal to CP minus R. CP minus R. CP is equal to 0.8274. We already find in part B 0.8274. 0.8274 kilojoule, kilogram minus 1, Kelvin minus 1. The kilojoule by kilojoule. Okay, 0.8274 minus R is R is 0.174. We already find in part A 0.174. 0.174. If you find the unit of the CPN, unit of the R will be same. That is, if you find kilojoule, kilogram minus 1, Kelvin minus 1. If you find the CP is equal to 0.8274 kilojoule, kilogram minus 1, Kelvin minus 1, R is equal to 0.174 kilojoule, kilogram minus 1, Kelvin minus 1. Same unit, we can uh, calculate. Okay, now CV is equal to be fine. CV will be 0.6534. 0.6534 in this unit one. Kilojoule, kilogram minus 1, Kelvin minus 1. Now this is the final answer. Okay. Now we only need this very in this question we have to memorize two things very carefully. One is this R. R is this R is not a R is not a universal gas constant. It is a characteristic gas constant. We already found in part A that R. That one thing we must memorize. Then this equation is mass relation R is equal to Cp minus Cv. Okay. Then calculating is very simple. Uh, in, okay. In next video we can discuss about part B question. Okay. Bye.